For some reason, the video keeps breaking back and forth, but I think I've started the third section of the video. Does this make sense, guys? So what is an asymptote is? It's the value at which the function does not exist. So if you get a tangent function, look for the angle where you get an error in the calculator. That's where you have an asymptote. You guys make sense?
Yeah.
Okay, so go to y1 and type in tan x. And if you graph it, you get like this. Of course, some calculators do give that lines here, so you know where the asymptote is clearly is. Mine gives something like this. Now, go to y2 and type in tan 2x. Tan 2x. Now you have changed the period, because now the period is pi or 2, 90 degrees. Now you can see you have more of these asymptotes between minus 360 and positive 360 because you've changed the period. So as the value of b increases, the number of asymptotes between a fixed angles increases. Are you guys getting this?
Yeah. Yeah.
Are you guys all clear about this? So what is the one thing that two things you have to remember when it comes to tangent is the period is pi over b, not 2 pi over b, and then you're looking for asymptotes. And what's the asymptote? It's the angle at which the function gives you an error value. That's an asymptote.
Are tan graphs and cotangent graphs like common, would you say?
No, that's why we hardly teach it. I have not seen a question in last few years.
Okay.
I definitely have seen a sine and cosine, yes.
Okay.
Ava, I want to particularly make sure that you're getting this.
Yeah, I mainly get it. Yeah, I feel like the sine and cosine makes a lot of sense, but I don't know. The tangent graph is just like looks weird, so it's like never something I've never seen really before.
Okay.
Like just like the repeating lines.
Yeah. Okay.
So it's like we've done asymptotes in school, but just not the graph, the tangent graph.
Okay. Okay. Emily has sent me the question. Is this a question?
Yeah. I don't know if that makes sense, and I don't have like all the exact wording.
Okay. Sine of angle D is 0.73. What is cosine of F?
Yeah, of angle F. And I didn't even know how to like approach that.
And you sure they gave the angle as D? Angle as 40?
As 40 degrees.
Okay. Why would they do it?
So I tried to do like arc sine.
Yeah, but why would they sine 40? That sine of
But
D.
it wasn't. I thought maybe it would be like a 30, 60, like 90 type of triangle.
My only question to you is, are you sure the angle 40 was given? Because sine inverse of 0.73 is 46.88 degrees, 47 degrees.
I thought it was, but just say it wasn't, then how would you?
Okay, then it's easy.
Solving?
Yeah, then it should be easy.
Okay.
Okay. Let's say the 40 degrees was not given, okay?
Yeah.
I can tell you a quick way. Sine of angle D is always equal to cosine of angle F, but always.
Right. So Oh, they're equal?
Yes, 0.73 is the answer.
Oh. Okay.
That 40 degrees is not even required, because sine of an angle is always equal to the cosine of the opposite angle of a 90 degree.
So I like did arc sine of
Okay.
0.73.
Let me
And then took that.
let me show you this, okay?
Yeah.
Can you see here?
Yes.
Okay. So this is angle D, this is angle F, okay? Fine? So sine D is 0.73, okay?
Mm-hmm.
So D is equal to sine inverse of 0.73, which comes out to 46.88 whatever, okay?
I wonder if I had my calculator
In radians.
the wrong.
Maybe it was in
wrong.
radians.
Let me look. Because I was getting like 0.8 something.
No, it was in radians.
Yeah, it is in radians.
Yeah. So then you do F is basically 90 minus of angle D, which is 90 minus 46.88, whatever it is, which comes out to 43.1 something. So if you do cosine of that one, if you do the cosine of that one, it comes to exactly 0.73 as well. So sine D will be always equal to cosine F. Always.
Okay. Okay. That makes sense. Wait, why did you did 90 minus,
Angle D, to find angle F is 90 minus D is angle F.
oh, to get angle F, right. And then when you got angle F,
Then I did the cosine of that angle,
okay.
which is 0.73.
Okay. Thank you.
Yeah, right here. Look at this.
Yeah. Okay. I kind of have the right like thought with doing like arc, but I mixed
That's why it's
some
very
things up.
important when you go to the ACT test, the mode should be degrees. When you're typing at any given point, you have to make sure you're not typing in pi. You have to typing as 180 in degrees, so that you are consistent, so that you don't make silly errors, because that can be pretty
So-
costly mistake.
On these problems, like, should it always be in degrees? Like,
Absolutely.
Would you know?
Absolutely. I've hardly done any problem in ACT where I need to go back to radians,
Okay.
or maybe zero, because it's not
That's good to
required.
know.
It's not required, because out of the 60 questions, 59 or 58 would be in degrees. Why would I change the radians for just one or two questions? And you
Yeah.
know what? Under the pressure, you'll forget to change it back, which has happened to my student, and he got 13 questions wrong.
Yeah, I think it was in radians from something at school, and then I just got into the test and didn't even think about it.
Yeah.
Okay. Thank you.
Yeah. Well, girls, it's been pleasure. I hope you have liked our class. Would appreciate if you want to refer our spring class to your friends. We have quite a bit of people signed up, but definitely make sure if you know anybody who might be interested, and if you think it's worth their time, please let them know to sign up. And you can just give my number, and they can call me.
Okay.
Okay.
Well, all the best for the December 12th. If you're taking Ava, I'll see you around. And Merry Christmas and Happy New Year.
You too.
Take care, guys.
So, no,
Thank you.
Yes.
I have one question.
Yeah. Please.
According to my SAT scores, like, what score do you think I should like try to shoot for?
Hold on. Let me
Like, what do you think
let me stop the recording, and then I can answer your question.
Okay.